Good morning, everyone. Can you please give me a green check mark in chat if you're with me, can see me, hear me, and everything seems to be working properly, and then we'll get going. Perfect. Check marks coming in. It's great. Give you guys a second. Excellent. All right, so I wanted to, good morning, everyone, again. I wanted to start by asking if anyone had any questions, issues, problems, anything like that with the safety unit. It's entirely possible you hadn't had a chance to look at it yet, which is fine. I just said, hopefully you can get it done by the end of this week, but if you had a chance, I know like 3 or 4 people submitted it. I will start marking them today, I guess, and sending out the passwords for the test. I think the test is like 10 questions or something like that. So it's not really a test. It's just kind of like a quiz. Abby likes the new course. Well, that's good. It's good to hear. Let's get into it a little bit first, and hopefully that doesn't change. Hopefully you still enjoy it. It has more of a kind of a textbooky course feel to it, which is kind of good. So yeah, if you hadn't had a chance to go through the safety unit, I'm going to ask that we get it submitted it's submitted on Friday, so that gives you Thursday and Friday to get it in. And then I will send out passwords over the weekend. And then we have Family Day on Monday, and then on Tuesday we have a professional development day for the teachers. So all the teachers in the district are going to be at Kelowna Secondary, learning about the new curriculum that's coming out. So I won't see you again until Wednesday next week. And then on Thursday, we're going to OC. Very busy time. So if we can get the safety unit learning guide in for Friday, I can get you the test password over the weekend, and you can write the test either on the weekend or the Monday or the Tuesday. So I'm hoping you guys can have that safety unit out of the way by next Wednesday. So that gives you kind of a week to get the test, which is only a few questions, and the learning guide done. And remember, the idea here wasn't to kind of beat you guys up with safety and say, you need to know this and this and be safe. It's more of an introduction to the course, how things are going to go, what the reading is going to look like, answering questions from the reading, things of that nature. So it's just a small little warm-up to what we're going to hopefully get into today. So I don't see anybody typing in some questions or anything like that. Yeah, Abby, so for Unit 1 lessons will work with me. We're going to start into the biology today. Nobody seems to have any questions on the safety stuff, and I don't foresee there being very many difficulties there. So what we're going to do today is we're going to start biology. We're going to start talking about biomes. And then we are going to spend some time on that. I mean, I'm only going to see you guys I guess we have class today, and then we'll have class next Wednesday. And that'll be it for like 2 weeks. We'll only have 2 classes just because of the Pro D days and the holidays and everything. So we're going to kind of ease into it and do that. So I'm just going to jump right into the biology. The learning guide I did mention was 32 or 4 pages long. All of the learning guides are a bit longer for the science compared to the math because there's diagrams and things like that. And it doesn't have to be printed in color. It would cost an absolute fortune to print it all in color. So I would recommend printing it in black and white. And a few people came in and grabbed them from me yesterday. So if you want me to print off these learning guides, bring them to the Friday activities, or you can send somebody in to come pick them up, or we can arrange for them to be somewhere so somebody that you know can access them. We can do that. I mean, printing in my building, I can fire off, 20 copies of a learning guide in about 5 minutes. We have a huge, big printer. You do it at home, it's slow, it wastes ink and paper, and I just want to be conscious about that. So if you are having issues printing, printer doesn't work, I don't even have a printer at home because I have one here at work, just let me know. Send me a message and we can get these things printed off for you and you can just come pick them up. Because 30 pages per unit times 10 units, it's a lot of pages of material, plus assignments, plus this, that, and everything else. So And it seems like, oh, that's so long. It's just not long. It's just what it is, because it's kind of like a little bit of a textbook for you and notes, and then there's some practice. So it's kind of a lot of things all in one. So that's the problem we run into. How long are we going to take? We're going to take, I don't know, probably about Unit 1, at least 3 weeks, because the first 2 weeks we only have 2 classes. So we'll be doing this stuff probably till the end of February, just depending on how far we get and things like that. Just kind of worked out a slow start to the semester. So what I'm going to do is, in the course, in Unit 1 Biology, there's the Unit 1 Learning Guide, which is PDF, and it is a few pages long, 30 pages or so. And basically, when you get in here, hopefully you have this printed. If you don't, it's not the end of the world. You can go through it on your own after or watch the video later. But you'll see it says Section 1.1 Notes, and then it tells you about the Eden Project and a bunch of other things, and then there's some diagrams here. What is a biome? And there's some blanks that need to be filled in, and then it's talking about the different levels. And so what I'm going to do is I'm going to go through these notes with you. So we're going to do the notes together. And then the learning guide, while I have it up, I'll just scroll down. So we're going to go through all these notes. It's a bunch of stuff. And then we're going to get down through all of these notes. And then at the very end of the notes, this one's a little bit longer than normal. At the end of all the notes, there are some like practice questions, true, false sort of stuff, kind of like the safety guide you guys did. It asks you to make a climatograph. So as we're going through the notes, we're going to maybe jump to the end of the learning guide to do some of the practice. So it says 1.1 practice on biomes. So there's a note section, which we'll go through together. And then there's a practice section, which you're going to go through on your own, or sometimes we'll go through it together in class. So what we're going to hopefully do today is we are going to talk about the biomes, and then we're going to get into the climatograph stuff, which is what I have up here behind me. You don't need to know about it yet or anything. And then it asks you to plot this information. So that's kind of where I hope to end today. So again, the learning guides are kind of broken into sort of 2 parts. You have a note section, which we will go through together. I'll go through it kind of behind me with PowerPoint. And then you guys can fill in the blanks as we go, ask questions, and then there's going to be a bit of practice as well. And then every once in a while I'll throw in an assignment, and I'll give you guys notice on that and time, stuff like that. But I don't think we'll get to an assignment probably for a couple more days. So if you had those printed off, that would be awesome. If you don't, no big deal. Could I come in today to get the learning guide and formula sheet? Yeah, for sure. And if you are coming in, just let me know, because I can have it printed off before you get here, so you don't have to wait for me to find it and then print it. But if you just show up, that's fine as well. I mean, you just might have to wait a minute for me to print it off. So if you're in the neighborhood and you're like, hey, we're getting really close to the end of Unit 1, maybe I'll just stop by and grab Unit 2. Or if you're going to come to one of our Friday activities, we could just give it to you then. Things like that. So we could make it happen. What should we have done for this week? You need to have the safety unit done, the safety unit learning guide done we'll say for Thursday or Friday. That gives you a couple days. And then the safety unit test should be done before the next class, which is next Wednesday. So we don't have so we do have a long time. Yeah, we have a pretty fancy photocopy machine here in our building, which can print lots of stuff. All right, so if you don't have this up, it's all good. You can just kind of go along with us, but I'm going to go through some information on the biomes. And the first unit is based on the biomes of the world. And in your data booklet, this map exists, and it has a breakdown of all the different biomes that you need to know about. And the biome section can get a bit tricky because you don't necessarily need to know like facts about all the biomes, but you should be able to compare the biomes. So why is a permanent ice biome a permanent ice biome, and why isn't it a tundra biome? So there are 8. We'll talk about them all, and we'll just get into it. Yeah, it's on the formula sheet. That is in the data booklet or the formula sheet. So the book starts, as well as the course, it starts talking about Project Eden, and that's this picture here on the right. So Project Eden is in the UK, and this is an old abandoned mine. You can see that, I'll get my cursor up here, perfect. These are all little cars. So this is how big this place is. It's huge. And they've enclosed a mine with these big kind of, I don't know, it's kind of like a giant bubble sort of thing here. And basically they've created an ecosystem, an environment in these big bubbles that are kind of closed off from the outside world. So it's in the UK, but they have a tropical rainforest and they have like a savanna. And I noticed Alex is talking about plains in chat, which is, we'll call grasslands plains, the same thing. So it's pretty cool. But it's not nearly as cool as this other option here. I don't know why they didn't put it in. So on the right side of your screen, this is called Biosphere. And this was an experiment. It's actually in Arizona. And what they did was they created this environment. And you can see it's quite large. I'll show you a picture of inside in a second. But they created an environment and they completely sealed it off from the outside world. And what they did was they wanted to know if they could put humans in and lock them off from the outside world, and if they could survive by creating their own sources of food, like agriculture, if the plants in there could produce enough oxygen for them to survive and not die. And some really interesting things happened. They actually went in, I think it was 95 or 96. They went in, here's a picture of the inside, one of those big things. So you can see some people there. And that's how big it is. It's huge on the inside. So this is kind of the agricultural area. It's kind of like Hunger Games without the killing. Although, really interesting thing happened, the people kind of got really angry. So the first time they ran this experiment, it was called Biosphere 1. They put 8 people in this environment for 2 years, sealed it from the outside world. And these people lived there. They lost a bunch of weight. Really interesting things happened to their bodies and metabolisms because they, instead of eating really high calorie foods, everything they were eating was, something they had to grow. So they couldn't produce, there was no sort of synthetic foods or anything. They couldn't use pesticides because that would be stuck in this ecosystem and they would, get really sick as a result. So it lasted for 2 years. The people stayed in. They found that the environment couldn't produce enough oxygen to sustain them, so they had to pump a little bit of oxygen in. It was kind of controversial. They didn't tell anyone. They were running this experiment and they pretended like it was all good. And they were pumping in oxygen and lots of really cool things happened. It has its own coral reef, it has an ocean, it has a rainforest. It was pretty interesting sort of thing. The reason I kind of really am interested in this is, if anyone seen the movie The Martian, just came out. It's a book based on a book by Andy Weir. Anyone read The Martian? That was one of the best books I've read in a long time. Basically, if you've seen the movie, it's a similar idea. Guy gets sent to Mars and he has to basically survive there. So, a book by Andy Weir. It's a really cool book, and it's kind of popular right now, this idea of sending humans to Mars and colonizing another planet. So this was a really interesting experiment that led to kind of some of the ideas that are being discussed now, even though it took place in the 90s. So was there any animals? Yeah, they had some goats to produce things like milk. I forget what other animals they had. You can look it up online. There's tons of information about Biosphere 1 and 2. They ran it twice. The second time, basically the management company kind of went into shambles and there was all sorts of controversy, and some of the old managers went to the Biosphere place and broke some of the windows and let, air escape to give the people a chance out. And it was just this big nightmare of a situation. So it didn't last very long the second time they ran it. And then a couple universities have run it since then, just kind of running experiments and things like that. So that's pretty cool. I like to draw things from the news as much as possible. So this is kind of something that's happened recently. This is called the International Center for Agricultural Research in Dry Areas. And what it is a seed bank in Aleppo, Syria. I don't know if I'm saying that right, but basically they have 148,000 different types of seeds that would grow in really arid regions, so places that don't get a lot of rain and things like that. Anybody immediately think of a problem with having a seed bank in a place like Syria in 2016 now? Sorry, Abby, just got your question. If the people wanted to be let out, I assume they would have free will and be able to be let out. I don't know what the exact sort of issues were. All the seeds are going to get stolen. Why would they get stolen in Syria, Alex? What's going on in Syria right now? The land is too garbage. Well, that's kind of one of these things, right? They have all these seeds so they can grow these plants that are specific to this dry region. Surely some of you watch the news. There's a large war. Yes, large war going on in Syria. Civil war in Syria. ISIS is starting to take over control from the government. Assad's fighting back. And basically where the seed bank exists, it protects all the genetic diversity of all of these plants in this dry region. So if you're like a rice farmer, and I guess not rice, I don't know what sort of things you'd grow, maybe different types of wheat or whatnot in really dry regions. If, a bug comes through and eats all of your crops, now you need to plant new crops. Where are you going to get your seeds from? So the idea here is they made this seed bank, they put it in Syria because in 1977 there was a war going on in Lebanon and they were going to put it there, but they're like, no, it's not safe in Lebanon. There's a big war going on. We'll put it in Syria. And then fast forward 40 years and now there's a big war in Syria. So what they did was they took samples of all of their seeds and sent it to this place. This is called the Svalbard Global Seed Vault and it's in Norway. And you can see down in the very bottom here, this is a map of the world. It's actually in the Arctic Circle. And what they've done is they've tunneled into the side of a mountain about 140 meters, and they have this giant seed vault in there, and it's very cold in there to keep the seeds from growing, because you don't want that to happen. As soon as they become a plant, they're no longer a seed. But there's 840,000 different samples, over 4,000 species of plant that are preserved in the seed vault. So why do you think we would need a giant seed vault, and why would it be put in a mountain? What would be sort of the advantages of this? And why the Arctic Circle? Why not put it in Kelowna? It's a pretty cool place, actually. You can see the outside of it here. Pretty interesting. Can people go in it? Yeah, there's scientists and things like that go in to monitor, the climate in there and things like that. And you need really low humidity, really cold temperatures. So why would we want a seed bank? So they don't grow. Yeah, well, it has to be cold so nothing's growing in there. That's a good point. It's like a giant freezer, yeah. They would put it in there for safety in a mountain because they don't think you can just bust open a window to get into a mountain. So safety, that's a big concern. It's on an island in the Arctic Circle, so no one lives on this island, which is pretty interesting. Think about this. Over the kind of history of the Earth, there's been sort of major catastrophes. The major volcanic eruptions block out the sun, plants start to die. Meteor impacts hit Earth, knocks off the dinosaurs or kind of sets them back for a couple million years sort of thing. So there are global things that happen. You get major events, earthquakes, volcanoes. If, a nuclear war broke out between whatever country, pick any sort of country in the world that's nuclear power, and nuclear winter happens, so all these bombs go off, the sun gets blocked out, all these plants would die. So what they've done is they're preserving the genetic diversity of Earth right now in this giant vault. So all the seeds from all different countries, so each country, generally speaking, each region of the world, like Canada has their own seed repository for things like we grow on the prairies, like wheat and canola and different varieties and really ancient varieties and really current breeded varieties. Different parts of the world have them, and then once you get sort of a seed sort of infrastructure of things that will grow in your country, you send it to Norway. and they'll protect the diversity. So, long story short, Syria, war breaks out. They want to protect the diversity of all of these plants that are really specific to this really dry, arid region. So they send all these seeds to Norway to put in the big global seed vault. It's locked off. It's in a mountain, so it doesn't have to worry about impacts from meteors or things like that. It's high up on the mountain, so tsunamis and things of that nature won't wreck it. It's just isolated in almost every way. So yeah, to protect major catastrophes. So we've kind of went into it a little bit, but why do you think it's important that we protect genetic diversity on our planet? Or is it important? Should we just say, forget about it? What's the point? And I'll give you a statistic. Maybe I can change your mind while you're maybe thinking. On our planet, Earth's roughly 4.5 billion years old, 99.9999% of every species that's ever existed on our planet has gone extinct. I'll say that again. 99.999, goes on a few more nines if you like, percent of every species that existed on Earth has gone extinct. So we're looking at things like in our lifetime, you'll probably see the extinction of a white rhino. That's no longer going to exist. There's thousands of species that are endangered. Is it important to protect this genetic diversity, or should we just say, forget about it? It's going to go extinct eventually anyways. Why should we save it? Interesting ideas? Make you think? Maybe you think too hard, perhaps? Humans, we are the master species. I bet if I put you in the ocean with a shark, the shark would disagree, Alex. I see a few people typing, so I'll give you a second. Because we'll just end up with genetically modified blobs. Yeah, they're talking about growing meat in test tubes, so you won't have to raise a cow to kill it and to eat its meat. You just grow the meat in a lab. Why not? The verb "all safe when something bad happens to Earth, we can make seeds in catastrophe, we can grow them." So that's kind of the idea, Taylor, is we'll be able to take all those seeds and continue on our life as normal. Zombie apocalypse or whatever. On boats, yeah. Or I'll put you in the jungle, Alex, and we'll see how you feel about a tiger stalking you or something like that. So we like to think we're at the top of the food chain, but we definitely aren't unless we have technology with us. So there you go. Some things to think about. So maybe something you didn't know before. And this kind of gets into what we're going to talk about for the next few days is biomes. So this goes in conjunction with your notes. There's some fill in the blanks sort of stuff you can do along the way. I don't unfortunately have the blanks underlined, but I'm pretty sure there's biotic and abiotic are two important things. And I apologize for putting so much text up on the screen. I'm normally not a fan of having PowerPoints with a ton of text, but I wanted to keep it really similar to what you guys are going to see in the learning guide. So, yeah, I just wanted to kind of mimic what you guys will see in terms of copying notes down. So if you have your learning guide with you, you could start filling it out. If you don't, you can always go back later. And this is just right out of the text that's built into the course. So biosphere, we use the word bio meaning living. So we have a biosphere, a biome, a biology. These are all studies of living things. And basically, we talk about the biosphere, and that's the whole Earth, and then we can break it down into biomes. And everything smaller than that, we can go down to ecosystems, and then we can go to habitats, and then we talk about individuals of the habitat. And the sort of important words we're going to learn about today are biotic and abiotic. So biotic kind of has this bio in it, so it means living things. And abiotic is non-living. And abiotic kind of sounds like antibiotic. So antibiotic kills bacteria. If you were to take antibiotics, your anti is against bacteria. That's what the abiotic is. So biotic is living, abiotic is non-living. And we have all sorts of different biomes in British Columbia. and we'll talk a little bit about them. But the biomes here are really kind of similar to the ones in New Zealand and other places in the world. So basically, if you can imagine taking yourself, throw you into a plane, fly you around for a while, you have no idea where you're going, set you down, and maybe blindfold you so you couldn't see the direction or anything. And you wake up and you're like, well, where am I? And you kind of need to figure out where you are based on sort of things around you. So the idea is, we're going to look at why the biomes are where they are. This is an image from the learning guide as well. So breaking it down, at the top you have the biome. So the biome is a big thing. It's a very large area. And then you can break down a biome into different ecosystems. So right now we live in Kelowna, we live in a biome. And within our biome, you can go, maybe I go down to the Rotary Marsh down by the Grand Hotel in Kelowna, and there's a marsh there. It's an ecosystem. You have plants and animals interacting, so that's an ecosystem. And then we can break it down even smaller, and we talk about where those ducks built a nest. That's their habitat. That's where the ducks have chosen to live. So the big thing is the biome. Then it breaks down into an ecosystem. And then we can go even smaller to a habitat. And we can go smaller even still down to individuals and things like that. So that is there. These are the biomes we're going to talk about, and it gets mentioned a little bit later, but they're very sort of different biomes depending on who you ask. Depends how you're defining what a biome is. So we talk about these 8, and there are many others, but for the purposes of this class, the test, the provincial exam, that idea, we're going to just only talk about 8. And one thing I should also mention is when you kind of read them, you have desert, grassland, permanent ice, temperate deciduous forest, temperate rainforest, tropical rainforest, and tundra. These are all terrestrial biomes. So a large majority of things that start food chains and food webs on our planet happen in the oceans. The oceans are kind of their own environment. Every biome that we talk about within Science 10 is all terrestrial, so land-based. So we're not going to talk about the oceans. That's not this class. So here's a map. This is on your data booklet. And just in chat, why or how are we defining the biomes? Why are the biomes where they are? I think if we imagine where we are, we're Kelowna right here. And Kelowna is a pretty cool place because we have really unique climate here. We're technically found in a boreal forest, but this desert here that extends up from Mexico all the way up through the United States, we're actually at the northern tip of it. So Oliver Osoyoos is considered a semi-arid desert, and we're just kind of at the very extreme north tip of this desert that extends up. And we have a ton of different sort of biomes within Canada, and specifically to our area, we have a bunch as well. All right, connect space from last year to places in relation to the sun. So we talk about sun. Taylor's in a temperate rainforest. Yes, you are, Taylor, you're on the coast. Deserts are sandy? Sure. Why are deserts sandy? Why isn't there any dirt in a desert? Why aren't there plants like a jungle in the desert? What makes a desert a desert? When you think of desert, what's the first thing that comes to your mind? Just, ideas. Why are the biomes where they are? What influences it? So hot. So that's temperature. So I think that's a great one. We're going to use that one for sure. Then somebody wrote dry. So what's the opposite of dry? That's an important one as well. Lack of water. I think, Anthony, you got it. So we talk about temperature. Defines how a biome is. You imagine permanent ice. It has to be cold. It's permanent ice. It's ice all the time. So that's going to be cold. We're talking about temperature. We talk about the rainfall and precipitation. So you guys said dry, and then Anthony mentioned wet, lack of water. So we're talking about precipitation. An area receives a bunch of rain. Does it mean it's going to have lots of plants? Generally speaking, it does. Temperature in relation to the oceans. So oceans is a really big one, and we're going to talk about that. So we have so far temperature, we have amount of precipitation, we have relations to the oceans, which isn't quite as obvious as you might think. What else do we have? Temperature, precipitation, relation to an ocean. Maybe I'll go back to the map here. What do you notice about, well, I guess these kind of lines maybe give it away, but this dark green is the tropical rainforest. And most of the tropical rainforests are found within this sort of central area. And why are all the rainforests here? Why isn't there permanent ice right here in the middle? What do we think about that? I think, Abby, you just got a really good one. Mountains and valleys, for example. Yeah, we're in a valley, so I'm going to extend your idea a little bit further. Abby, I'm going to talk about elevation. So how high you are. Why are there no plants growing on the top of Mount Everest or any mountain that's over about 3,000 meters? Why is there no plants there? Why can't plants grow? Elevation plays a huge role. I think that's a pretty good start. We're going to look at a bunch of different reasons, but I think we are on the right track in a roundabout way, which is good. So I'm just going to jump in here. It's too cold, and Abby, you nailed it. Oxygen. If you see pictures of mountain climbers that climb these 8,000 meter peaks, like Everest is 8,881 meters, they take bottles of oxygen with them. There's no oxygen up there. What do plants need to survive? Well, they need carbon dioxide, a little bit of oxygen. There isn't any up there. Literally, it's called the death zone for a reason, because you just can't survive there. If I stuck you up above 8,000 meters and gave you as much food and water as you could ever consume, you would die. There's not enough oxygen to sustain life at that elevation. You can't catch on fire. Well, when you're packing oxygen tanks, you can. So we got temperature, we got precipitation. One that we kind of missed was latitude. That's what I was trying to refer to. So we'll talk about what that means. Elevation, ocean currents. So we got all of these, which is great. And the big two are temperature and precipitation. When we talk about precipitation, we're not specifically talking about rainfall, but we can also talk about snow, mist, fog. There's ocean environments that exist only because there's kind of like a fog that rolls in each day. So these are all abiotic factors. We talked about biotic being living things. These are abiotic. Rain isn't living. Rain provides moisture, which is essential for life on Earth, but it isn't a living thing. Temperature, not a living thing. So these are the abiotic factors. These are the non-living things that influence where biomes are where they are. This map comes up, I think, on every provincial exam I've ever seen. This map appears. It is a very kind of important map. It takes the two main abiotic factors. It takes temperature and precipitation, and it plots them. So it looks a bit weird, but after you look at it for a second, it kind of makes a little bit of sense. So you can see up the vertical axis here, we have the precipitation. So 0 millimeters, 50, this is in centimeters, 0, 50, 100, 152, 250, 300, all the way up the side. And then along the bottom, we have temperatures. So temperature, we go from about, on Earth, minus 20 or colder, and then we go up to, 30 to 40 degrees. That's about the temperature range. Extremes on Earth, minus, 30 to plus 40 or 50, depending on where you are. So what we can do is, if I tell you, I say, hey, this place where I am right now, they receive, I don't even know, I'll just make it up. They receive 250 milliliters of rainfall each year, and the temperature averages about 30 degrees. You'd say, okay, well, I can tell you what biome you're in. 250 mils of rain is up here, so I go across, and then 30 degrees temperature. You'd be in a tropical rainforest. That's where you'd be, based on only two factors, identifying precipitation and the temperature. I mentioned Kelowna is kind of unique because of kind of where we're located in terms of oceans, and it's so dry here in the summer. We get some snow in the winter. It's kind of an interesting location. And you'll see that some of the biomes, like technically we're in a boreal forest, which is this big brown blob here, but they all kind of overlap a little bit. So you could be, just looking at this specific spot right here, or right here is an even better example. There's 1, 2, 3 different biomes all kind of overlapping here. So when we say Kelowna is the northern tip of a desert, well, in the summer we have average temperatures that are really high. We don't get hardly any rain all summer. So we're kind of like a desert in the summer. And then the fall and spring, we get more rain. So we move kind of over to the boreal forest, or maybe even down towards the grassland. I've heard people say that if we let forest fires burn in the Okanagan Valley, the trees wouldn't grow like they do. And technically we'd almost be a grassland. We have the conditions for a grassland. We don't get a ton of rainfall. We have fairly warm temperatures, so we'd likely be down here. So Kelowna's in this really interesting spot, kind of in this area, where our average temperature is probably around 10, 15 degrees year round. And then we don't get a ton of rain. So, we're kind of, at this triple point here between temperate rainforest. When we get our rain, we're kind of like a rainforest. When we don't get our rain, we're kind of like grassland and kind of boreal forest all at the same time. So, yeah, if you look at really old pictures of Kelowna, it's just plains full of grass, not a lot of trees. If you look at the south slope, kind of behind me of the Kelowna, where the fire went through, trees are starting to grow, but there's just a lot of kind of grass up there. If you look towards Black Mountain, that whole hillside, there's no trees. Why is there no trees up in Black Mountain? It's just a grassland. That's what this area was like before we started to suppress forest fires and things like that. So something to consider. So this map's super important. You can see the biomes overlap, but usually you can find out kind of where you fit in based on the map. So how far should you be working in the learning guide, Alex? Just kind of go with me and we'll see where we end up for today. So this kind of goes along with the notes in there a little bit. So in the learning guide, it says instant practice, or it might be in the actual lesson built into the course, the online textbook, if you will. So we'll just go through these right now real quick. Number 1 says the region has an average annual precipitation of about 175 centimeters and an average temperature of 5 degrees. So I'm going to go back. I'm going to find 175 centimeters of rainfall. So there's 150, 200. And it says the average temperature is 5 degrees. So I go 5 degrees up to the 175, and I find myself right here. So if I told you those two things, you would tell me that you lived in a boreal forest. Okay, let's try the next one. Ranges in temperature between 0 and 20 degrees Celsius and receives about 100 centimeters of rain. So 100 centimeters of rain and from 0 to 20. So if I go to that 100 centimeters, 0 to 20, that's referring to this kind of light green here, which is a temperate deciduous forest. Temperate deciduous. Deciduous is a really important word. Does anybody know what deciduous means? If a tree is deciduous, what does that mean? And Abby, that's a good point. Big White is kind of world famous for its snow ghosts. That's what they call those trees up at the top that are completely covered in snow. And that has kind of to do with the unique place where Big White is. It's a 2,000 meter peak, but it's on a plateau. It's not surrounded by any other mountains. So a lot of clouds go across it and build on it as moist air tries to go over top of it. It condenses, and you get lots of snow and things like that. So that has to do with the unique geography of Big White and where it lives. And Abby and Taylor, you guys both nailed it. So the word deciduous means leaves fall off. So deciduous forests have really leafy trees. The Okanagan, we have pine trees. We don't have a lot of leafy trees. There's a few birch and and aspen in the Okanagan, but mainly once you get out of the valley, it's just pine, fir. So we're not really deciduous. We don't have deciduous trees. Does anybody know why sort of a tree would want to lose its leaves? What sort of is the bad thing about not losing your leaves as a tree? If you think about winter specifically, and sort of what we were just talking about. So it's important to lose your leaves because if you keep them, bad things happen. There is some evidence to say that the cold temperatures that those areas receive, it would be hard to sustain life. Yeah, that's one. And if you think about the actual physical stress on the tree, so you've all this surface area, all these leaves out in your tree and the snow falls on it, now all of a sudden you have all of these leaves holding this weight and your branches break. So deciduous trees will lose their leaves because of the cold temperatures. They're not able to grow in the winter. And the actual strain of holding up the snow would just break all of the branches. So if you're a tree, you don't want to lose your branches. That means you don't live. All right, number 3 is between -18 and -8 and has a low average annual precipitation. So it doesn't even say how much. This one's fairly obvious. Between -18 is right here and 8 and low precipitation. It's a really specific region. It's called tundra. And then the last one, region has high precipitation and about 15-degree temperature. So I find 15 and go to the highest precipitation in the 15-degree category. And we're at a temperate rainforest, which is an extremely specific biome, where Taylor is right now. Only exist in a few spots, here, New Zealand, a little bit of Australia. So there you go. Those, you guys are really good at reading graphs. I know from math, you guys did a great job of that section. And this graph is one that'll come up. So it's important that you understand what you're looking at, how to read it, because it is something that you will see a lot of. So let's just look at the different factors. So we talked about latitude. Right here we have this north temperate zone, and we have a tropical zone, and then a south temperate zone. You can see there's not a lot of land mass in the south temperate zone, and you'll notice the boreal forest in which we live is this kind of yellowish brown here now. That only exists in the northern hemisphere because the majority of land mass of our planet is in the northern hemisphere. So that's why we exist there. And just speaking in general, if you go really close to the equator, you have a tropical rainforest, then you have a temperate forest, meaning lots of rain but lower temperatures. Then you go to boreal forest, then you have a tundra, and then you have permanent ice right up at the top. So that's kind of how it breaks down. And if you went to the southern hemisphere, it would look exactly the same as that. So we talk about latitude. 0 degrees latitude is the equator. And at the equator, the rays of sun are almost directly overhead all of the time. If you are between the two tropics, you literally will receive 12 hours of sunlight each day, year round. As soon as you go out of the tropics, you get into the temperate zones, northern and southern, then you have what we call seasons. So as the earth tilts away from the sun, you end up with our seasons. So if you live in the tropics, between the Tropic of Capricorn and the Tropic of Cancer, you won't experience seasons like we do in the Okanagan. You'll experience, like, they call it a rainy season and a dry season, but their seasons aren't defined by temperature. The temperature is pretty constant. So tropical zones, warm temperatures, high precipitation. There is really a lot of precipitation. All the rainforests are here because the sun's rays are hitting the oceans almost all the time. That water needs to evaporate. It rises, and then once it goes over land, it cools and falls, and they get lots of rain. So in the temperate zones where we live, we have seasons. When we're pointing towards the earth, we have summer. When we're pointed away from the earth, we have winter, and that's kind of unique to the northern and southern temperate zones. If you live in the tropics, you don't experience the seasons like you do in those other zones. Yeah, that's a good, interesting point. If you were to live in Thailand, which is a tropical rainforest, you have a rainy season, and it literally just like, they call it the monsoons. It just rains and rains and rains and rains and just never stops. And even in sort of like drier places, you'll end up with like rain every day. So it'd be really hot, dry in the mornings, and then it'll rain in the afternoon. So there's things like that happen as well. So latitude affects precipitation. Just finishing off the latitude notes. So at the equator, you get all this heat produced from the sun. The sun is always directly overhead and evaporates a lot of the moisture at in the oceans there. It rises, cools, falls back to Earth over the land where it's a little bit cooler. And these areas receive the greatest amount of rainfall, creating tropical rainforest. There's other things that have to do with it, like ocean currents and mountains, which we'll look at in a second, and that's what kind of makes the temperate rainforest special. And my grandpa lives in Ecuador. Cool. Winter is 26 to 28 degrees Celsius. Yeah, that's why as Canadians we travel to Mexico and the Caribbean in the winter, because it's our winter, but there it's nice. And obviously the seasons in the southern hemisphere are opposite. So if you were to celebrate like Christmas in Australia, it's the middle of their summer. So we think, oh, Christmas, snowy, winter wonderland and all that around December. And then if you were to live in the southern hemisphere, Australia, you don't experience snow. That's their summer. It's hot, like 40 degrees, and they don't have the sort of wintry ideas that we have of Christmas. So elevation is a really important thing, and I did mention a little bit, we talked about Mount Everest being 8,000 meters high, and nothing grows up there because there's not enough oxygen, there's not enough carbon dioxide. The air is so thin, the molecules are so spaced out. It's literally called the death zone once you get above 7,000 meters. Because you end up with just conditions that nothing can grow in. I shouldn't say nothing. Some things like bacteria and things like really small things can survive, but they don't choose to grow there. This is, if you've ever driven from Vancouver to Kelowna, you've experienced this sort of thing before. If you're in the Fraser Valley, if you imagine leaving Hope. So you're at the Fraser River, it's about to empty into the ocean, so you're really low in terms of elevation. And then you drive through Hope, or you don't, maybe you just continue on Highway 1, but all around the highway there's these big deciduous trees. There's lots of leafy trees there on either side of the highway. And they have these really, big trees with leaves. And then you get a little bit higher, so you're driving up past Hope, and then you get sort of climbing the mountains. And you'll see that the trees change from these leafy, deciduous type trees into a more a conifer type tree. So you have your pines and your firs, your spruces. And then you get really, really high. So you don't get to drive at an extreme elevation, but the Penasque summit's about 1,800 meters. The mountain peaks, like the coast mountains, they have these really sheer faces. They're covered in snow all winter. You get avalanches, take all this dirt away. Nothing grows there because they're 2,000 meters or above. You don't have a lot of things to grow. And you end up with this kind of, we call it tundra. It's not necessarily tundra. Just nothing lives there. And then you get even higher. So in North America, even, we don't have a ton of really high peaks. Most mountains around Kelowna are, max out just over 2,000 meters. But elsewhere in the world, we have peaks that are up to 8,000 meters. The major mountain ranges like the Andes, Himalayas, and nothing can grow up there just because there's no nutrients, there's no atmosphere to speak of that will sustain life. So there's no heat, it gets very cold. I was hiking this summer just outside of Pemberton, kind of think like down by Whistler area. And it was the middle of summer. I kid you not, it was August. Me and my friends were hiking over this mountain pass to get into a place called the Stein Valley. And it was snowing on us in the middle of summer, like the hottest time of year. The middle of our summer in August, we're up above 2,000 meters and it was snowing. Atmosphere is very thin up there, hard to breathe, and you can get snow year round when you get over a certain elevation because there's not a lot of heat retained in the atmosphere and it's just cold. So elevation plays a huge role. We had rain jackets, that was it. It wasn't fun. It was warm out. It was still like, 15 degrees, but it was snowing. Highest permanent settlement known, La Riconda. I assume that's probably in the Andes. That's not sounding like a place outside of the... Sounds like Alberta. Oh, Mason. Are you from Alberta? So there's places that are high, even in like Afghanistan. There's really extreme mountains there, and the Karakoram Mountains are there. So K2, all of the K mountains. There's lots of permanent settlements that are extremely high there. Ocean currents is another one, and one thing that I want you to get straight in your mind is students sometimes think, if you're next to an ocean, you're going to get a lot of rain, because we live in British Columbia, and we look at Seattle, we look at Vancouver, we look all the way up to Prince Rupert, all the way up the coast, all the way up to Alaska, and you think, you're next to an ocean, you get rain, because that's what we're used to. The closer you get to the lower mainland, the more rain you get. You live in Seattle, you get lots of rain. Oregon coast, tons of rain. But what happens when you go a little bit further south? I'm going to kind of jump back to my map of all of my biomes here. I don't like that one. Let's go back a little further. Here we go. So we have this temperate rainforest here along the BC coast. But when we get down a little bit further, we have a little bit of grassland. And then right here we have a desert. So if you think about places like Los Angeles, Cabo San Lucas, Mexico, these places are on an ocean, but they don't receive rainfall. So what is special about where we live is we have an ocean current, and we have a jet stream driven by that ocean current that blasts weather systems at us. So we get tons of rain because we have a jet stream and we have an ocean current off of our coast. If you live down in Los Angeles or Cabo, Mexico, all the way down like Puerto Vallarta, Acapulco down here in Mexico, these places are right on the ocean, but they're desert. They don't receive hardly any rainfall. So just because you live next to an ocean doesn't automatically equal rainfall. Africa's a really great example of this. Look at how big this north coast of Africa is here. And you'll notice there is no rainfall here. This is complete desert, Sahara Desert, all the way through the center of Africa, right next to an ocean. No rainfall though. No ocean currents here. We have a special ocean current right here. We have our jet stream that blasts rainfall onto us. You get between the tropics here, and it's a little bit different story, but basically we receive the rainfall we do because of the ocean current off of our coast. So that's what's special about these temperate rainforests. We're really cold, so northern British Columbia, Prince Rupert, these would be really cold areas. They're very high, they're far away from the equator, but they don't receive, they receive a ton of rainfall, so it keeps them nice and warm because there's an ocean current there to protect them. So that's why we are a temperate rainforest on our coast. I was hoping to get a little bit further than this, but this is where we're at. So a climatograph, we'll look at a couple. If you want to have a go at making one of your own, you can, but we'll worry about it next day. So climatographs are sort of year-on-year averages of how much rainfall and how much temperature an area receives. So we're talking 30 years or more. And we often use these two factors, like that graph we were looking at before, the precipitation and temperature, are kind of the most important ideas in terms of why we have the biomes that we do. So here's